We're going to determine algebraically if the equations that they've given us are inverses of each other. And then we're going to look at it graphically to see if we could also tell graphically whether they're inverses of each other. So first of all, algebraically. If I would take y equals 3x minus 6 and algebraically want to find the inverse, well, step one, anytime you're dealing with inverses, that's where x and y get switched. So I'm going to switch my x and y and then solve for y. So add 6 to both sides would equal 3y. And finally, I can get y by itself by dividing both sides by 3. Does that match with the equation that they've given? They have y equals x minus 6 divided by 3. We got y equals x plus 6 divided by 3. So they don't match. They're not inverses. For the second one is starting with a negative x squared plus 3, and they restricted the domain to be bigger than or equal to 0. Start the same way. We switch the x and the y. So algebraically, if we want to find an inverse, we switch the x and the y. I'll move the 3 over to the other side. Here I have a negative y squared. You can either divide by a negative 1 or multiply by a negative 1 to get rid of that negative. Doing so would change this side to negative x plus 3. And now that I've got y squared by itself, I can square root both sides. Remember, when you square root both sides. Now, looking at the equation I have up there, do you see how it has a 3 minus x? Negative x plus 3, can you see that that's the same as 3 minus x? So sometimes we're looking back at our original equation when we write things because we might want to change things a little bit. In this case, instead of writing negative x plus 3, I'm going to write 3 minus x. Now this part, because they restricted the domain of the original function, when we switch x and y, that means that our range is going to be restricted on our image graph. So because x is bigger than or equal to 0, on my inverse, y has to be bigger than or equal to 0. And since y has to be bigger than or equal to 0, that means I'm only going to take one of those equations. Will I take the plus one, or will I take the minus one? Well, the only way that it can be bigger than or equal to 0 is if I take the positive one. Does that match with the equation they've given us? Yes. Now part B, said look at them graphically. Look at them graphically and see if you can tell that one is an inverse of the other or not. So what we're going to do is we're going to look back at our original equations. I'm going to graph the first one in green, the second one in blue. Same thing over here. I'll graph the first one in green, the second one in blue. And we'll see if, looking at the graphs, if we can tell that they're inverses or not. So I'll draw a grid. Starting with the first one, 3x minus 6, it's going to be a line with a y-intercept at negative 6. It has a slope of 3, so I'll go up 3 over 1. So I'll have the point 1, negative 3. Up 3 over 1, I'll have the point 2, comma 0. And I'll draw a line through those points. This is the equation of 3x minus 6. Our second equation that they want us to graph in blue was x minus 6 divided by 3. Now the form that this is in makes it hard for us to graph because it's not in y equals mx plus b form. So we have a couple of options. If you're not liking the form that it's in, you can plug in some values, use a table of values to graph it. Or you can say, how could I rearrange this to get this into y equals mx plus b form? So in this case, having that all divided by 3 means the x is divided by 3 and the negative 6 is divided by 3. So if I rearrange this, x divided by 3 is the same as multiplying x by 1/3. Negative 6 divided by 3 is the same as negative 2. So one way I could do this is I could rearrange that equation and get my equation in mx plus b form. I now know that minus 2 is my y-intercept. A slope of 1/3 means up 1 over 3. So I would have the point 3 comma negative 1, up 1 over 3. I'd have the point 6 comma 0. And there would be my line of the second graph. Table of values. Can you see that if you plugged in 6 for x, 6 minus 6 would be 0, 0 divided by 3 would be 0, you would get the point 6 comma 0. Other ones that might be nice to plug in, numbers that divide nicely by 3. You might plug in 9. What's 9 minus 6? 3. 3 divided by 3, 1. So you might use a table of values and get 6 comma 0 and 9 comma 1. Once you have a couple of points, you could draw your straight line. Now, graphically, is this an inverse? Well, graphically, you can tell if something's an inverse if you can reflect it over the line y equals x. The blue graph does not look like taking the green graph and flipping it over that line. Okay? Another thing that doesn't match up is with an inverse, the x and y coordinates get switched. If I switch 0 and negative 6, I would get negative 6 comma 0. But that is not on my blue graph. So graphically, I can verify that they're not inverses of each other. For the second equation, we were going to graph negative x squared plus 3 in green, and then the square root graph in blue. Thinking of transformations, starting off with the green equation of equals negative x squared plus 3. Thinking of transformations, you could take a regular parabola x squared. That negative would be a vertical reflection, making it point down. The plus 3 would shift it up 3 units. That will give me a vertex at 0, 3, and my parabola will be going down. However, this question also told us that it has a restricted domain. We're only going to graph it when the x values are bigger than or equal to 0. So it's only going to be this half of the parabola. We have 0, 3. We have 1, 2. We have 2, -1. The blue graph is asking us to graph y equals the square root of 3 minus x. Transformation-wise, we see that everything is inside the square root, but when we look at it, the order doesn't seem to be right. So we're going to have to, again, manipulate this equation a little bit. Usually we have our x's first. So instead of writing it as 3 minus x, I'm going to write it as negative x plus 3. If I write it that way, can you see that that negative is a horizontal reflection? And the 3 is going to be a horizontal translation. Which way is it going to go, left or right? You see the plus 3, you think left. But this is where our special note comes into play, right? Because we've got our horizontal reflection and our horizontal translation. So before we can graph this, we have to factor out that negative. And it's actually going to be 3 to the right. So imagine your square root graph. Horizontal reflection, it's now pointed the other way. Shift it 3 units to the right. We'll get 3, 0, 2, 1, and negative 1, 2. When looking at these graphs, they do look like a reflection over the line y equals x. When looking at the corresponding points, 0, 3, change to 3, 0. 1, 2, change to 2, 1. 2, -1, change to -1, 2. So everything matches up, and we can see graphically that these ones are inverses of each other. Okay, so for questions for practice on this one, we have 7, 8, 11, and 13. I'm going to put stars over top of 11 and 13. 11 and 13 are types of examples where you have the tools to be able to solve them. The wording is a little bit different. The type of question is going to make you think a little bit. You will get questions like that on your quizzes and tests. You will get questions like that on your provincial final, ones that you have the tools to be able to solve it, but the wording is a little bit different, and so you're going to have to use your understanding of your skills to be able to figure them out. So throughout the year, I'm going to introduce you to those because you have to start developing that skill in, here's a new type of question, can I figure it out? Hopefully by the end of the year, when you get to your provincial final, you've got lots of those in your experience so that there's not too many of them on your final exam.